Hello friends, it's Prajwal Pathak this side and you're watching my YouTube channel PyGuru. Friends, from this tutorial we are going to start a new series, and in this new series we'll try to apply our Python knowledge to get information about space. Okay, so I have given this series name as PySpace. You can just search about this section in my YouTube channel. So let's move further and try to implement our first script here. And in this tutorial we'll be learning about how can we use Python and NASA NEO API to get information about near Earth objects. Okay, what are near Earth objects? Generally, these are asteroids and comets which came close to Earth, and they can be of two types: hazardous or non-hazardous. So we'll try to get information about the asteroids using Python here. So for this, I'm going to use a library called the request. We have been using this library for quite some time, so let's see how to use it. It's very easy. Just you have to type pip install request to install it. It's not available by default, so you have to install it first. And for this tutorial I am using a Jupyter notebook. Doesn't matter whatever you use, you can use IDE or a text editor too. Okay, so I have already installed the request library, so I'm just going to import it. So import request. So let me just type here how to install it. Pip install request. Okay, this is how you install it. Let me just run this cell. And now here what we are going to use, NASA NEO API. Okay, so for this API, see here, this is the website of the NASA APIs, free APIs. These APIs are free and we can use it. I'll give a link of this website in the video description. You can check that from there. So what you have to do, first of all, you have to visit this web page and then generate yourself a API key. Just open this web page, link is in video description, and click this generate API key. So you will be scroll down a little. Here you have to fill your first name, you have to give your last name, you have to enter your email and leave this empty, or just click sign up. Okay, and it will give you a API key. What is the API key? Simply it will be a key like this. Okay, it will help us to access the NASA API. Okay, and so first generate yourself API key, and now let's move forward to our API part. So see here, just scroll down on the website from the overview, and the first one that we are going to use is see, there are lots of APIs listed here like APOD, Asteroid, NEOwS, Donkey, Earth. We'll be using a few of its APIs in later tutorials. So for this, the asteroid that we are going to use is this one, Asteroids NEOwS, Near Earth Object Web Service. So we have to use this. So what you have to do, just maximize it. Okay, and now you will see it's written how to use the API. So what you need is, all you need to find out is, you have to just copy this copy this link. So let me just copy this link. Okay, come here, let's come here, and let me just run this cell too. So what I did, just let's create a variable called URL and store the link that we have just copied and paste it here. Now see, the API key that you will get, you have to paste it here inside a variable called API key. See, this is my API key. If you want, you can use mine, but better if you generate yourself another API key. So you have to store this API key in a variable called API key. Then, and the next thing is, let's just put a f string here. Now see, this API, before accessing it, it takes three things. First, the start date from which we want to start the observation, and then the end date on which we want to end our observation, and then finally the API key. We have already got the API key. Okay, so we need two more things, the start date and the end date. So what I'm going to do, I'm going to create a variable called start date. So the today's date is 2020 06 and 05. Okay, 5 June 2020, and the end date will be 2020 dash 06 and dash 06. So July, sorry, 6th June 2020. Okay, so this is our start date and end date. Now see, the API can give you data for only 7 days, so do not try to put here 5 and here 28. So it will not able to give you data. So it can only give you data for 7 days. Here I want data for only 1 day, from 5 June to 6 June. Okay, here see, before URL we have put a f, so here we can use now the you can use it as a f string. So here I am just going to start date equals start date. Okay, we are passing 2020-06-05 here, and then here we are going to pass the end date I hope you already know how to use the strings in Python. Okay, and here finally we have to pass the API key. So basically just in curly braces we pass the URL. So our API key is this, and let's try printing URL and let's see if it's fine or not. Let's see. So yep, it looks good. This is the API key. Start this is this, end is date is this, and API key is this. Okay, so it's perfect. Now let's try to make a request. How to make a request? We are going to create a variable called R, and inside the request library that we have imported, see we have function request. You can call it a method, and this method takes the URL of a API or a website and responds that website or API will give us data. So I'll just going to pass the URL here that we have just generated here. Now let's create a variable called data and see we can apply a JSON method on it. See the API will give you data in a JSON method. So I want the JSON method, so JSON data. So I have applied r.json here, and let's try finally printing data here. And now see here we are getting a lot of data. Okay, so we have to extract data of our interest from this. So how can we do it? Let's create another cell here, escape A, and let's create a variable called total. Okay, you can give it anything. So first of all let's see few things here. If you see this is a dictionary. Okay, what is a JSON data? JSON, it's a simply you can think it like as a Python dictionary. Here you can see that there are total 19 asteroid information between 5 June to 6 June. Okay, and then there are near Earth objects. Here is the asteroid data, all asteroid 19 asteroid data. You can just read it, but here don't worry, I'll try to extract and explain you in detail. Okay, so let's see how can we do it. So first of all what I'm going to do, I'm going to extract how many number of element count is total there. See a bigger dictionary, which is this, its name is data. We have created it here, and here to access the total element count we can simply pass the element count variable here. So I'm just going to pass this, and if you try printing total, you will get it's written 19 here. Okay, here I'm not using print function. You can if you are using some normal IDE or text editor, you have to apply print function and then total. Okay, but in Jupyter notebook it's we can print anything without using print function. Okay, so you can we already know it. So let's try to find out now. Extract all the asteroid information into another variable called NEO. Okay, near Earth objects. Here what I'm going to do, I'm going to create see the bigger dictionary is data, and the thing that we want is this near Earth objects. We are going to store it here. Done. And if you see, I have by mistake put two quotes here, and now let's try printing NEO. So see here we have extracted only the asteroid part data from here. Now see here is the date, and then this is the first asteroid information, and if you scroll down there will be second asteroid information from here, and then third asteroid information from here, like this. Okay, so there will be total 19 asteroid informations stored in this. So what you want, suppose you want to get the asteroid information of first, see there are 19 asteroid information. Suppose you want only the first one. How can you do it? It's very easy. Let's create a variable called first, and see now our dictionary name is NEO. See this is our NEO. So how to get the only the first value? So NEO, and then you have to pass the key as this. So let's just pass it, paste it here, and now see its value is a list. If you see its key value is a list. So in list there are total 19 elements. Each element is a dictionary. So suppose you want the first element, so you can pass 0 as an index here. Now if you try printing first, you will see you will be able to print only the first asteroid information here. So this is the first asteroid information here. First of all, this is the ID, then your reference ID, then name of the asteroid, then NASA JPL URL, then absolute magnitude, estimated diameter, all these things. Don't worry, we'll try to extract it. So this is how you can extract the asteroid information by index. You can pass 1 to get the second asteroid information, 2 to get the third asteroid information, because we know that indexing in Python starts from 0. Okay, so that's why. So this is the thing by getting information by index. But suppose you want you already have some asteroid name and you want to get the data of that particular asteroid. See here, today, that is a 5 June, in the midnight there will be asteroid called 163348 2002 NN4, which is a quite large website as compared to other websites, and it's going to pass quite close to the earth. So I want to know about this particular asteroid 163348 2002 NN4. What I'm going to do, let me just copy this name. Okay, and see, it's going to pass today. Okay, 5 June to 6 June. That's why I have passed the starting date as this and end date as this. Okay, so what we are going to do, we are going to apply a for loop on this NEO, which stores 19 asteroid information, and we are going to check if that 19 asteroid information has the asteroid information of our interest, which is 163348 2002 NN4. Okay, why I'm interested in this, because it's a quite wide website. NASA is saying that its width is around greater than few buildings or a football field. So let's see how can do it. So what I'm going to do, first of all, I'm going to create a variable called all asteroids. Okay, and then see, our all asteroid information is stored in the dictionary called NEO, but again it has a key called date key. Okay, I don't want this. What I'm going to do, I'm going to create a extract from that NEO. Sorry, let's just go a little above, and sorry, where was your NEO? This, and from this I'm going to extract the value of this key, date key. Okay, so I'm just going to pass here. It's like this, and finally let's try printing all asteroids. So it's nothing different. You will get the same thing. See, only the date key is removed now, and again it has 19 19 asteroid information. So what I'm going to do, I'm going to apply a for loop. So for asteroid in all asteroids, if asteroid, now see, when we extracted the first asteroid name, it has quite many data, like it has name, it has ID, it has estimated diameter, like this. If you know the ID, you can extract the asteroid by ID. If you know the name, you can extract the asteroid by name. I know the name, so I will try to extract the asteroid by name. So here, if sorry, so if asteroid name, okay, name is a key, is equal to this 163348 2002 NN4, what I'm going to do, I'm going to print the asteroid. Oops, sorry, we haven't applied this thing here. So let me just get back here and then again try printing asteroid, and then finally we are going to break out of the loop. Now this will give me the information of this particular asteroid. So here we have some thing here, we are not getting anything, so it may be 2002 NN4, everything looks fine. Then why you are not getting data? Asteroid NN4, print asteroid. Sorry, let's see, let's go above. And why we are not getting anything? We are not getting anything. We are not getting anything. Why? 2026 5. So let's try running it. Let's go a little above. Don't worry, we'll find it. 2002 6 8 2016 2017 2018 2016, then 2019, then 2020, then 2020 KS1. Okay, so it looks like it's not in this dictionary. So what I'm going to do, don't worry, we are just going to change date a little. So we are going to start from 6 and end to 7. Okay, from 6 June to 7 June. Just you have to run this again, and then here you have to run this again. So this time, and let's try running it again, and let's see if it's here we have some error, key error 26. Okay, it will be the 6 here, not. So yep, so this time we are getting an value here. So actually it wasn't visible on 5 June. Okay, it's coming to earth in on 6th June. Okay, so that's why we were not getting any data. So I fixed it. What I did, just see here, I have passed the start date as 6th June and the end date as 7th June. Okay, and then we have just changed it here, all asteroids equal neo. See here, we have already stored it in a variable called start date, so I'm just going to pass start date here. So this time we do not have to manually change it every time. So here we are getting the asteroid information, but see, if you might not be able to read information like this. So for that, we are going to import another library called, sorry, we are going to import another thing called from pprint import pprint. Okay, just import it like this. Pprint stands for pretty printing. It's available by default, you do not have to install it. Just here, instead of print, type pprint. Okay, what does pprint do? It's pretty prints the dictionary. See, initially all the data was just cluttered inside one, quite messy. This time it's printing quite nicely. Okay, so here we have the information about the asteroid 163348 2002 NN4. Okay, so I hope you understood the mistake. What is was this? It was simple. The asteroid wasn't passing on 5th June. Instead, it was passing on 6th June. That's why we were not getting the data earlier. Okay, so let's try extract now things from this. So our dictionary's name is asteroid, and we will try to extract data from it. So let's see how can we do it. So first of all, asteroid name. So asteroid, and then you have to pass the key name. The key name is, see this, you can simply pass it like this. Let's try printing it. So name, and if I just run this, so its name is 163348 2002 and then 4. Then asteroid ID. So asteroid ID is this. See, key name is ID, so I can simply pass ID. So its ID is 2163348. Now NASA maintains asteroid IDs, so you can get information about them using the ID part. Now let's try to get a URL of this uh, asteroid, so that we can get more information about it. Asteroid, here you can see the key is NASA JPL URL, NASA for National Aeronautics and Space Administration, JPL for Jet Propulsion Labs. Okay, it's a NASA company, and it's quite active in space related research. So asteroid NASA JPL URL. So let's print it. So this is the thing. If you want to know more about the asteroid, you can just copy this URL and paste it in your browser, and it will open the web page of NASA for this particular website, asteroid. So you can get all the information about it, JPL. So this is the whole information about this particular asteroid. You can get more data from here. Okay, now let's try extracting further things, which is called absolute magnitude, which is the luminosity comparison. Okay, so let's see how can we do it. It's very easy. Asteroid, and the our key name is, let's try to find out. Yep, our key name is this, absolute magnitude H. Absolute magnitude is the luminosity comparison. H means solar system bodies. So this asteroid is a part of solar system, that's why it's written underscore H here, and its value is 20.1. Now let's try finding its diameter. Again, we are going to create a variable called dia. Okay, and here asteroid, and then we are going to pass the key as, what is the key which is storing diameter. So this is the key. Okay, estimated diameter. So let's copy it and paste it here. Oops. So let's paste it here, and let's try printing dia, and let's see what it's printing. It's printing for diameter in 4 units: kilometers, meters, miles, and feet. Okay, so this is, see, each key is storing two more values, that is minimum estimated diameter and maximum diameter. This is in kilometers, this is in meters, this is in miles, and this is feet. So suppose you want to know the average diameter of this asteroid in meters. So how can we do it? Let's we do it like this: average diameter in meters. So okay, and now we have stored all the diameters in a variable called dia. So I'm going to extract it like this, dia, and then the key name is meters. How to find the average of, suppose 1 plus 2 by 2 will give us the average of 1 and 2, which is 1.5. Similarly here, so, and then the minimum plus maximum divided by 2 will give us the average diameter. Okay, and let's just copy the whole thing from here, control C and then control V, and here we are going to print out max. Okay, and finally we have to divide it by 2, but we have to apply the BODMAS rule, which is quite like this, so I'm putting parenthesis here. So okay, so let's try finally printing out the average diameter in meter, which is our variable name. So let's try printing out and see its average diameter is 410 meters. So it's a quite wide website. Okay, and it will be passing uh, near to the earth tonight. Okay, so let's try to extract further things. If the asteroid is potentially hazardous, potentially I don't know the spelling, I think this is the correct spelling. Okay, so it's potentially hazardous, so asteroid, and then we have to find the key name, which is potentially hazardous asteroid. So let's just print it here and let's see if it's potentially hazardous or not. So it's giving true, it means it's potentially hazardous, but you do not have to worry about it. Will pass quite a long distance from Earth. Okay, so let's try to find out close approach date. When will the asteroid will pass from the Earth, near to the Earth? So we are going to create a variable called date, and then what I'm going to do here, this is the close approach data. Okay, so instead of date, let's use it like this, close data. Okay, you can give it a name. So from the asteroid I'm going to extract a key, which this is a key name. Let's try printing close data. So it's printing it like this. If you want to pretty print it, you can just use pprint here instead of print. You can apply pprint on dictionaries. Okay, so it's now better printing it. So this is a close approach date, this is a close approach date for full, this is a close date approach. Now you can it's a what timestamp value you can convert into a date. Okay, this is the missed distance, this is the relative velocity. So let's try to find out missed distance. Don't worry, in the end I will try to convert this timestamp in date. Don't worry, I will try to get it. So missed distance equals close data. Okay, this is a dictionary name, and from this we are going to extract it, this value, missed distance. Okay, and then let's try find to print missed distance. Here we are getting some error, list index must be integer. Oops, sorry, my fault. See here, it's a list again. Okay, so now we have to pass values here. So first of all, before applying the missed distance, you have to pass 0 as an index here, because see, this list has only one element and that element is a dictionary, so its index is 0. Okay, so that's why we got an error. So missed distance is this, astronomical distance is this, lunar distance is this, kilometers is in this, miles is this. So this much kilometers this asteroid will pass. Okay, and here you can raise that the close date approach full is 6 June 2020, 3:20 a.m. Okay, so it's in midnight 3:20 a.m. Okay, I hope you understood. Let's try to find out relative velocity. Well, sorry, which stands for relative velocity. Okay, and let's just copy this thing, paste it here. Only the key will be different this time, which is the relative velocity. So let's copy this and let's paste this here, and let's try printing rel, which is relative velocity. So kilometers per second, it's 11.14 kilometers per second. Kilometers per hour speed is 40126. So 40,126 kilometers per hour, and miles per hour speed is this. Okay, relative velocity. Finally, we are going to print if this asteroid is a sentry object or not. What is a sentry object? See, JPL maintains a list of all the asteroids in upcoming next 100 years which can be potentially hazardous to Earth. So a sentry object is that particular asteroid which can do some harm to Earth. Okay, so it maintains a list so that if the asteroid ever comes, it can be destroyed using certain techniques. Okay, or can be deviated from the path of the Earth. Okay, so let's see how can if it's sentry or not. So how to do it? Asteroid, and then finally we have to pass the key name. Our key name is what is our key name for sentry? Is sentry object. Okay, this. So let's just copy it and paste it here, and let's run it. It's sentry object false, so this is not a sentry object, so there's no meaning of getting afraid of this asteroid. Okay, so we have did nearly extracted all the information. Finally, let's try to convert it this value in timestamp value in a date. So remember, we will only be able to convert it if it's a timestamp value. I do not know if it's a timestamp value or not. Okay, so let's see it. Here I'm going to create a cell above. Here I'm going to import one more library called from datetime import datetime. From datetime library import datetime class. So dt equals datetime datetime dot from timestamp, and we have to pass the timestamp value here. So our timestamp value is stored in a dictionary called closed data and in a key, but before that we have to pass a list index as 0 and then this thing close approach data. If you are not getting any error, it means if it's a timestamp value, otherwise it will give some error. So let's try printing dt. So invalid argument. Okay, so it's not a timestamp value, I think. Or let's see if this happens works or not. Store it in this, and let's try printing first. Print date, sorry, then yep, and let's pass it here. Okay, so it's not a timestamp value, sorry, my fault. Generic timestamp values are this, it's something else. So yep, this is it. This is how you can get asteroid information using Python and NASA NEO website. Okay, near Earth Object Web Service API. So yep, this is it. There are a few more ways to call this API. You can get it like this. See, suppose you already know the ID of the what we call asteroid, then you can use this link API. Everything will be same. Here you have to pass the ID. You can use a f string to call this ID, and then the API key you have to pass it here. And if you want to know all about all the asteroids, you can use this API key, this API URL. Okay, so yep, this is it for this video, guys. If you love this video, if you learned something new, you can leave a like or dislike below this video. If you are new to my channel, subscribe it. Thank you. See you in the next video.